Yes, welcome to Mr Samwealth MTH classroom. So, like I said, we have to continue on our function and graph unit 1 of MTH 102. So, this is the continuation, and I'm going to be using the NOUN MTH 102 manual or course materials. So, now let's quickly continue from this place, and we have been able to cover the definition of function from our previous classes. Now, we can see all this. A function is a relationship between two variables such that each value of the independent variable for each value of an independent variable is exactly one corresponding value of the dependent variable. Now, the domain is the function. The domain of the function is the set of all values of the independent variable, that is all value of x, as we have said before. Now, for which function is defined, so that is it. And we're able to also define range in our previous classes. They said the range of the function is the set of all values that taken on by the dependent variable, that is all value of y, that is all the output value. So we talk about that as well. So and they also say a function is a correspondence from the first set called the domain to a second set called the range, such that each element in the domain corresponds to exactly one element in the range. So that's it. So let's quickly look at this diagram from the manual. Let's look at the diagram from the manual. Let's look at this diagram from the manual. Let's look at this diagram from the manual. So I believe you can see this diagram. This is a domain. Domain pour into this and it become input. It pour into this machine and it become input. Now the machine process this, work on it, work on the inputs, work on the domain, then it draws it out, it become output, then it become the range. Once it become the output, that is the range. So that's a simple explanation of this on this. So and that is that, so we don't have to be following it word by word. Let's quickly go to the main thing, but please pay attention to this. They say although function can be described by various means such as table, graph, and diagram, they are most often specified by formulas or equations, which we'll be dealing with now. Formulas or equation. Now, for instance, the equation y equals to 4x squared plus 3 describe y as a function of x. For this function, s is the independent variable and y is the dependent variable. Now, example. Let's try to work on this example. So I need to bring the board forward so that we can guess what we are learning. So I need to bring the board forward. So these are the examples before I bring the board forward so that we understand what we are learning. Yeah. Now we have to decide whether relation are function. Now, which of the equation below define y as a function of x? A, x plus y equals 1. B, s squared plus y squared equals 1. C, s squared plus y equals 1. D, s plus y squared equals 1. Now, we are going to be solving this now so that we will understand. Like I told you in the end of the previous class, I told you that the first thing we have to understand is that when it is given as an equation, this is an equation. The first thing we do is to make the dependent variables, that is the y variable, as subject of the formula. So when we make it the subject of the formula, by ourselves looking at the result that we have on our right hand, we will be able to tell if y will be having two values. You know, when y is having two values, y is our output. Once this is having two values, it is no more a function. We can there call that a relation. So, and this MTH 102, I told you from the beginning of the class that we learn this course in order to relate or to be able to solve real life problems using mathematical terms. That is what we are doing. So I will have to bring the board forward so that we can solve all this and we can understand it. So that's it. Now, from the screen before, we were shown this question. They said deciding whether the relations are function. Now, how do we decide if a particular relation is meant to be called a function? It's a very simple thing. The first thing is you have to understand that when you are given it in an equation form, the first thing is to make the dependent variable subject of formula. That is, we should make our y subject of formula. What do I call subject of formula? That is bringing our y to the left hand side, standing alone, then every other thing going to your right hand side. We are going to be doing it now. Then you are going to understand it. From there, or from that equation, you can now tell if it is a relation or function. Are you getting it? Now, if the relation are function, because not all relations are function. If the relations are function, that's what I mean. Because not all relations are function. Now, solution. The question A says we should decide whether this relation is a function or not a function. Not all relations are function. Pay attention to that. Now, why do we say that some relations are not function? I've told you before. Any relation that is not obeying the rule of one input having one output is not a function. But they are relation, but they are not a function. Let's go. X plus y equals 1. Welcome back. Draw the power supply. So x plus y equals 1. The first thing we have to do here is to make y subject of formula. Y is our dependent variable. Now that will be y standing alone here equals to, we are going to transfer our x to this side, then it will become 1. Remember that this x is having positive invisible plus here. Once it travels to this other side, it becomes minus x. Now this is our dependent variable and this is the right hand side. Because why do we make this to stand in this form? Because y must be equals to f of x equals to what? 1 minus x. I get it. So we can easily write this alone as f of x equals to 1 minus x. Are you getting it? So for us to decide if this is a function, we're going to look at the equation given. When we should take 1 minus x, definitely our output value will be 1. Like will be a value, not two values. It should be a value. Definitely, yes, this is a, yes, it is a function. Because we have to decide whether it is a function or not. Let's go to the next one, B. What do we have in your B? We have x squared plus y squared equals to 1. Remember the normal step, make y subject of formula. Let's go. That will be what? Y squared equals to 1 minus x squared. Because this is coming to this side. Are you getting it? It's having plus. When the plus cross to the other side, it becomes minus. Then we cannot make y squared solid of formula. We are told to make y solid of formula, not y squared. So we take the square root of both sides. Then we have this square root of y squared equals to square root of 1 minus x squared. So we can now say that this square cancel our square roots, remain ordinary y equals to plus or minus. Why do we have plus or minus? Because of the square roots. Anytime you're adding square roots, it comes with plus or minus 1 minus x squared. Definitely, if we should solve this question, it's going to give us either plus 2 or minus 2, something like this, or plus 1 or minus 1. Sorry, plus 1 or minus 1 will be the value. Then that means that our y is having two answers. Our y is having plus 1 or minus 1 as the value, which means that this is not a function. Are you getting it? This shows that this is not a function. You can now say it is not. No, you can say no. No, it is not a function. Or you can just put it as it is not a function. Anyhow, it is not a function. No, it is not a function. I'm thinking of how I can manage the board instead of cleaning. So let's go to C. The question C, what do we have there? We have x squared plus y equals to 1. And we are told to ask to show if it is a function or not. Now, the normal thing we do, make y solve the formula, it become with y equals to this x squared travel to this side. You don't need to be showing this arrow. I'm only showing this so that we can understand. You don't need showing the arrow. I'm showing this so that we can understand. So equals to 1 minus x squared. Now 1 minus x squared. If you look at this now, automatically our y is standing alone. Definitely we can see our y is going to have a value. It's going to have a value because if the value of x is 2, it will become y equals to 1 minus 2 squared. So it will become y equals to 1 minus 4. It will become y equals to minus 3. Definitely our y will be having a value. Are you getting it? So if our y will be having a value, definitely it is a function. You can say yes, it is a function. I believe we are getting it. Now let's solve the last one, which is D. And D, we're given x plus y squared equals to 1. So we make y solve the formula. We have y squared equals to 1. The x goes to the other side minus x. Then it becomes, take the square root of both sides. Then we have y equals to square root plus or minus 1 minus x. Are you getting it? So this is not a function because it should be having two value of y, either 1 plus 1 or minus 1. So it is not a function because a function must have one value of output mapping to one value of input, one input to one output. So you can say no, it is not a function. I believe you understand that. Hope my video is clear. Yeah. So I'm going to show you how to solve this question in the other way through the screen. We're going to see the graph, so we know that this A is a straight line, this is a cycle. I will show you everything on the screen, but I just want us to move to example 2 so that we can understand things before removing the board so that we can see the screen. Now, we have to determine if this is a function or not. They are all relation, but we have to know if they are function or not. We follow the same method like I showed in example 1. Now let's go solution. Question number 1. Sorry, question A. We have x squared plus y equals 4. Is this a function? How do we know? Make y solve the formula. That is the dependent variable coming to the left hand side, standing alone. It should be y equals to 4 minus x squared. If y equals to 4 minus x squared, definitely if the value of x squared is 1, so this is a function. Yes. Okay. I easily answer this. Yes, it is a function. This is a function. This is a function. What do I mean? Let's assume if the value of x, this is a function. If the value of x is for example, maybe I told to find e.g. You know this is f of x. It's the same thing as f of x equals to this. F of x equals to this. Yeah. E.g. for example, I'm told to find f of x equals to 4 minus x squared. Then I'll say find f of x when x equals to 3. So it's very simple. You just say solution. You just imply this. That will be f of 2. Or you can give the question as define f at 2. You just say f of 2 equals to what? 4 minus 2 squared. Anywhere you find x, you put 2. And that becomes equals to 4 minus 2. 4 minus 2 squared equals to 4. and that is equals to 0. That means f of 2 equals to 0. Definitely our y is having just one output value, not that f of 2 equals to 0 or 1. No, it is having a value. Remember, a function must be one input to one output. That's what I'm trying to show you. Now the b, let's go to the b. We're given x squared plus y squared equals to 4. Make y solve the formula, it become y squared equals to 4 minus x squared. It become, take the square root of both sides, become y equals to, plus or minus follow square root, plus or minus 4 minus x squared. Now from here, now we can easily see that the value of our y will be given 2 values or 3 values. This is what I mean. For example, if we should solve for this now, it should be the value of our y will be equals to either minus 2 or minus, let's say f of x, because it can't give you a value. It should give you 2 or more value because of this plus or minus. That is going to give you 2 value. So this is not a function. You say no, it is not a function. So I believe with these 2 examples, we should be able to solve or decide whether a relation is a function or not. Okay. So we'll be moving to the next thing. Let me remove the board so that we can continue on the screen to the manual. This is the screen viewable. Okay. Let me zoom the screen so I can see it's right. Okay. Alright. So we've been able to cover the example parts where we are told to decide, and this part they said deciding whether the relation or function. We have been able to solve it on the board, and I believe we've understood it. So we can go through the manual and also look at what they're talking about. But I believe I've given us the best way to quickly understand it. The first thing is to make y solve the formula, that is bringing y to the left hand side, then every other thing go to the right hand side. So by yourself you will see if the value of y will give 2 values or just a single value. When it is given just a single value, definitely it is a function. But when the value of y is resulting to 2 values, it is not a function. That's it. So can we quickly move to the next thing? So yes, I told you that I'm going to show you the graph. See, now they said know that the equation that's assigned to 2 values plus or minus to the dependent variable for a given value of the independent variable do not define function of x. I've told you before. Now for instance, in the part B where x, all this one, so the equation becomes this. Are you getting it? When you substitute the value of x, so you have plus 1 or minus 1. I showed it on the board the other time. So now let me quickly show the graph. Now we want to show the graph of the 4 equation. For the first equation, this is the graph. X plus y equals to 1. This is the graph. X plus 1 equals to 1. Now this is a graph of a straight line, and you can see that this line cuts this Cartesian plane on x axis. It cuts it on a point, not 2 points. When it cuts it on 2 points, or when it cut the y-axis on 2 points, definitely it is not a function. It's cutting the y-axis on 2 points, so this is a function. Are you getting it? And you can also see the second one, x squared plus y squared. So automatically this is a circle on the graph. It's a circle on the graph. It has y value here, it has y value here. It is not a function. So the third one, you can see the third one on the screen. You have this is a function because it only cuts y-axis on a point, on this point of 1. Are you getting it? This is not This is not a function because it's cutting y-axis on 2 points. It's cutting y-axis on 2 points, this point and this point. That is, if the graph is cutting y-axis on 2 points, it is not a function. If it is cutting x-axis on 2 points, it is still a function. But when it cuts y-axis on 2 points, it is not a function. That's what it means. That is, the value of y will now be 2 values. So when the value of y is 2 values, it is not a function. So now this checkpoint, be faithful with this, ensure you solve all this. This checkpoint 1, solve it, then you submit on the group. Solve it and submit on the group, then I'll be able to check if you're right or not. So we'll be able to decide for ourselves. Now, and the example 2 was the one I solved. I believe you saw the example 2. They said determine whether an equation represents a function. Then we'll start with this. X squared plus y, it is equals to 4. Now this x squared plus y squared equals to 4 as well. Now, from here we solved, and by ourselves we find out that yes, this is simplified and it is a function. And we find out that this second one is not a function because we'll be having 2 values of y. So we'll be having 2 values of y. It's not a function. So let's quickly move to the next one, which is function notation. That's unit 1.4 under MTH 102. Unit 1.4. Function notation. When using an equation to define a function, you generally isolate the dependent variable on the left hand side. Now, I've told you before, just make your y solve the formula. That is what we are saying here. For instance, writing the equation x plus 3y equals to 1. Now, the first thing to do is to what? Make your y solve the formula. You transfer this x to the other side, become 1 minus x. Then it remains 3y equals to 1 minus x. Now, the next thing, we divide both sides by what? 3. Then we have y equals to 1 minus x all over 3. So we can easily indicate that y is the dependent variable. In function notation, this equation has the form f of x equals to 1 minus x all over 3. I've shown you in the other example. I showed f of x. Our y is the same thing as f of x. Or we can also read this as f at x. It does not mean f times x. It means f of x or f at x. We read this as f of x or f at x equals to 1 minus x all over 3. Now, we can easily find out that the independent variable input, that is the input, is x. Once we have written it like this, we can see that the independent variable is x. That is, the input is x, and the name of the function is f. What am I trying to say? The independent variable, this, is x, and the name of this function is f. That is it. Now, the symbol f of x is read as f of x or f at x, as I've said, and it denotes the value of the independent variable output or the value of the function of the number x. The value of the function of the number x. That's it. For instance, the value of f when x equals to 3 is f of 3 equals to 1 minus. Are you getting it? 3 all over 3 equals to this 1 minus 3 will give us minus 2 all over minus 2 over 3. So I'm going to show a lot of example on the board. So just follow the screen, then we'll solve it in reality. Now, the value f of 3 is called a function value and lies in the range of f. This means that the point 3 comma f of 3 lies on the graph of f. This means that the point 3 and f of 3, this is x comma y. Try to understand. Under coordinates, we always put our coordinate as x comma y. Coordinate is never written as y comma x. This is 3, which is the value of x comma the value of y. F of 3 lies on the graph of f. One of the advantages of the function notation is that it allows you to be less worldly. For instance, instead of asking what is the value of y when x equals to 3, you can ask what is f of 3. Instead of asking what is the value of y, you can just say what is f of 3. Now, let's note this. We are going to solve, so I just want us to go through the material, then I bring back the board, then we understand things together. Now, the notation, I've said it before, f of s does not mean f times s. The notation describes the value of the function as x. It means the function as x, that's the meaning. Now, example 3 that we'll be solving now, they say evaluating a function. Find the value of the function f of x equals to 2x squared minus 4x plus 1. So we are going to solve this. Let's check the other one so that we can solve everything together. Then the diagram as well, we are going to look at it. If you look at this equation or expression or relation, you see that this is quadratic expression. Because it's a quadratic expression, definitely should give you a curve, a parabola. I get it where it records the value of x in two places. I get it. So that is it. So let's check the other example. And after the other example, you should be able to solve this checkpoint. So I want us to solve this example 3 and this example 4 together once I'm bringing the board further. So then we try to, let me check if we have example 5. Okay. This example 5 as well, I think we should do it once so that we understand it better. It's not something difficult, it's very simple. Or let's handle example 4, 3 and 4. Then in the next one, still in this video, I will handle example 5. So let me just bring up the board. Now this is example 3. Let's try to solve this and let's see what which will result. Evaluating a function, find the value of the function. Now, even you seeing this expression, you would have known that it is a quadratic expression. It's a quadratic expression. So you by yourself, you should know that the value of x, if we should solve it normally, it will be giving us two value of our y. That means our y cannot just be a value. From this expression, if you want to see that it is a quadratic expression, by yourself you should know that it is not a function. But let's just test it. Let's see. Solution. Let's see. Now we have f of minus 1. So from the question, now the equation is f of x equals to 2x squared minus 4x plus 1. Now our first one is they say we should find f of minus 1 equals to, that's 2 open bracket minus 1 squared minus 4 open bracket minus 1 plus 1. Then we have, that's what, 2 open bracket 1 minus, okay, minus times minus 4, minus times minus gives us plus 4 plus 1. It gives us what? 2 plus 4 plus 1. That's equals to what? That goes by 6, 7. Now let's check the second one. The second one is what? F of what? Input 0. We are inputting 0. That's 2 open bracket 0 squared minus 4 open bracket 0 close bracket plus 1. Then we have what? 2 times 0, that's 0. 2 times 0, 0 minus 4 times 0, 0 plus 1. Automatically, this results in what? 1. Good. Let's check the third one. Then they give us input of 2. Input of 2. So we are inputting 2. That will be f. That will be 2 open bracket 2 squared. Am I correct? 2 squared. Minus 4 open bracket x. Open bracket x. Plus 1. So we have what? 2 open bracket 4 minus 4, sorry, open bracket 2. 4 times 2 gives us 8 plus 1. Then we have what? This one too as 8 minus 8 plus 1. So automatically it gives us 8 minus 8 gives 0. Then we have what? 1 as our result. So we can see that this is the way to input it. But by ourselves, we can now determine what the asking. We have when x equals to, I think, when x equals 0, we have the value as 1. When x equals 2, we have the value as 1. So from this alone, we should be able to decide if it is a function or not. We should be able to decide if it is a function or not. It is not 1 to 1. The question is f 1 to 1 or not? So I say it is not 1 to 1 because two different values of x, two different value of x yield or give the same value of f of x. Two different value of x give the same value of f of x. So this is not 1 to 1. So that's it. Let's go to the next example. Let's quickly start example 4. Example 4. They said if f of x equals to x squared plus 5x plus 5. Evaluate each of the following. Now the first thing is solution. Don't have time to waste. Now A is what? The question is, let's do now the question for f of x equals to x squared plus 5x plus 5. Now the next we have what? F inputting x plus 2. Now we are inputting x plus 2, so that will be equal. So anywhere we find x, we put x plus 2. Now from this, this x squared become x plus 2 all square, because this is x. X squared become x plus 2 all square, because anywhere we find x, we put x plus 2. That's what we are doing. Plus 5, inputting instead of x, we put x plus 2. X plus 2 plus 5. Now let's open the brackets. This means we have to open the bracket. Let me just teach you a simple logic that you can use to open this kind of second degree faster. It's very easy. You can say give this square x, give it square, that's s square. Let me do it on my own jota. Let's assume this is my jota. We have x plus 2 all square. Look at it very well. Now this x, give it square. This 2, give it square. That's 2 square. It is always plus, because even if it is minus 2, it will still be plus. Now after that, you now say this x times 2 times this 2. That is x times 2 times this 2 again. It will now give us 4x. Remember that this is plus. If it is minus, it will give us minus 4x. If it is plus, it will give us plus 4x. So it is plus 4x that will be at the middle, plus 4x. Automatically, when we open this bracket, it will give us x squared plus 4x plus 2. 2 square is what? The same thing as 4. Are you getting? And if you want to open it in your normal secondary school way, it is very simple. That's x plus 2 times x plus 2. That's the meaning of this x plus 2 square. Then if you begin to write it, it becomes x, this x multiply everything in this bracket. Open bracket, x plus 2. Are you getting it? Plus 2. Multiply everything in this bracket again. Open bracket, what? X plus 2 again. Are you getting it? Now it becomes x times x squared plus x times 2, that's 2x plus 2 times x, 2x plus 2 times 2, that is 4. Then it becomes x squared plus 2 plus 2x plus 2x plus 2x give us plus 4x plus 4. That is how we have this and this. You can get it. So that's it. So just try the one you think you understand, and it should be able to help you. But the one I'm giving you, I think is faster. It's very faster. That one is very simple and faster. So depending on how you understand it, very simple and faster. What do I mean? If you are given x plus 2 all square, you just say give this one square, that's x square, give this one square, that's 2 square, that is what? 4. Or you put it as 2 square so that you can understand it. Put plus. This one, you don't put the sign yet until you know. If this one is minus now, it will be 2x times minus 2 times this. Minus 2 times 2 is minus 4 times x, that's minus 4x. I get it. If it is plus, it will be what? Minus 2. It will be x times plus 2 times 2 is what? Plus 4x. That's it. That's the first thing. It becomes x squared plus 4x plus 4. That's what I did to get the other one. So if you can learn that, you can solve your mathematics faster than everything. So let's move on. We still have a long way to go. Then this one become plus 5 times x, 5x. This 5 times this 2 give us what? Plus 10 plus 5. Now let's move on. That will be equals to, let's try to collect the like term. Let's bring the one that have likely terms together. X squared plus 4x plus 5x plus 5x is 4, 10, and 5. They look alike. Plus 4 plus 10 plus 5. So it gives us what? X squared plus 9x plus 14, 19 plus 19 plus 19. This is the value. I believe you understand that, and I believe we are very correct on that. So it was 19. So let's go to the next question. The next question is B. That is F inputting minus X. We are inputting minus X. Let's go. It become anywhere we find these are our A. Sorry, these are A. Anywhere we find X in this, we put minus X. Let's go. It become minus X squared plus 5 open bracket minus X plus 5. Now let's go. It become minus x squared is the same thing as what? X squared. Because minus x times, because minus x squared means minus x times minus x. Minus times minus give us plus. X times x give us x squared. You understand? It's still the same thing as x squared. Plus, no, this one will not be plus. Plus times minus. This plus times this minus. It gives us what? Minus 5 times x give us 5x plus 5 plus 5. Now this is our value for this, and I think we are through with that. So that's it. So the next thing is example 5, and we're going to be solving the example 5 now. So I just need to clean the board so that we can handle the example 5. So I believe you understand that. Okay. Now let's quickly do this example 5. We'll still clean the board. Example 5 is look different, but it's very simple. So they said let's f of x, let f of x equals to x squared minus 4x plus 7. Now we have to find A, F inputting x plus change in x, x plus change in x, F inputting x plus change in x, and B, we have to find F inputting f plus change in x minus f of x all over change in x. Now it is a very simple task that we can do together. Now faster, let's write solution. Now that will be the first question. What's our question? Our question is f of x equals to x squared minus 4x plus 7. Now the first one, we have to input what? A as what? F inputting x plus change in x. Now let's go. Anywhere we find x, we put x plus change in x. So x squared, it becomes x plus change in x squared minus 4. We input x plus change in x because our x becomes x plus change in x. That's what I need. Now plus 7. Let's solve on. This become, open this using that same system that I taught you, that same strategy. Give this one squared, that will be what? X squared. This times 2. It gives us what? Plus 2x change in x. Because this x times change in x gives us s change in s. S change in s, they are not the same thing with x. S times change in s give s change in s times 2 give 2x change in s plus give the last one squared. Now be what? Change in x square. Are you getting it? Change in x square. Now, after that, we move to this one. Minus 4 times x, it gives us minus 4x. Minus times plus give us minus. 4 times change in x give us 4 change in x plus 7. Just permit me to manage it there. Plus 7. Yeah. After that, this becomes what? Do we have a like term there? Do we have a like term? Yes, we have. No? We don't have a like term. Let's have x square. X square plus what? 4 change in x. So we have x square plus 4 change in x. So do we have a last term? I don't think we have a like term. That's true. I don't think we have a like term. So that's our final answer. So there's no like term there. So automatically, you can say therefore f of x change in x, f of x plus change in x equals to x squared plus 2x change in x plus change in x squared minus 4x minus 4 change in x plus 7. These are our answers for that. Now, for the B, I would like us to clean the board because it will take a lot of this my board. So now let's go for the B. We have our f of this one is x plus f into bracket x plus change in x minus f of x minus f of x all over change in x. This is what we are dealing with. So if I'm to solve this my B, and we advise, since we have solved our f of x plus change in x before from our question A, we can just bring the value of this f of x plus change in x into this. Then we have the value of our f of x before as the original question. We can just substitute it. It makes it easier because if we start solving, we still go through this process again and still come down. We still go through this process to get this f of x plus change in x. So I would just like us to bring it from our value already. So this becomes what? Let's go. The value of f of x plus change in x, that will be equals to what? X squared plus 2x change in x plus change in x squared minus 4x minus 4x minus 4 change in x plus 7. Now we now put this minus everything on our question. The question is f of x equals to x squared minus 4x plus 7. So it will now be minus. Permit me to write it down here, so because this side cannot contain. You can just say minus open bracket. Now our f of x will bring it down. The whole of this will bring it into this bracket. It become x squared minus 4x plus 7 in bracket. That is, this is our f of x plus change in x minus this is our f of x plus change in x minus f of x minus this is our f of x. You get it? Now we can now say all over change in x. That's it. Now let's keep solving. This become, we have to open this bracket. This minus will affect everything inside this bracket. This is having invisible plus. Minus times plus, plus, minus times minus, plus, minus times plus, minus. Sorry, minus times plus, minus, minus times minus, plus, minus times plus, minus. That's what we are doing. We are opening the bracket. Let's go. It become x squared plus 2x. Let me just write it in the other side so that we can understand it. It becomes x squared plus 2x change in x, 2x change in x plus change in x square minus 4x minus 4 change in x, 4 change in x plus 7 minus times plus s squared. That minus times plus give us minus s squared, then minus times minus give us plus what, 4x, then minus times plus give us minus 7. Are you getting it? All over changing x. That's what we are dealing with. Now from here, now we can now easily cut out the one that can cut each other. X squared and minus s squared plus s squared and minus s squared can cut each other. I think we have another one like 4x plus 4x and minus 4x. Minus 4x and plus 4x can cancel each other because it will give us 0. Do we have another one? I think that's 4. Yes, that is all. Let's write out the remaining. So it becomes 2x change in x plus change in x squared minus 4 change in x no, 7 can go. 7 plus 7 minus 7, they cut each other. So it becomes this is what we saw. We only have 2s change in s, change in s squared, and we also have minus 4 change in x. That's it. All over was change in x. From here, in mathematics, when you have a plus b plus c all over d, it is the same thing as a over d plus b over d plus c over d, everything over d. So we are going to apply this same logic on this. That means each of this is overchanging s, that we are going to get our final result. So that we can end the class there. We can try to have our 2s change in x all over change in x plus change in x squared all over change in x plus minus 4 change in x all over change in x. So we can easily say change in x cancel change in x, and we have 2x plus change in x cancel the square, because change in x square means change in x times change in x. So change in x cancel the square, remain change in x, minus change in x cancel change in x, remain 4. So this is our value here. So I believe we should be able to handle any question under it. So let's go back to the screen so that we can quickly look at the checkpoints and every other thing, that we close it there. Yes, let's go back to the screen. So I believe we can see it clearly. So yeah, so back to the screen. So we've been able to cover this example 4, example 3, and example 4. We've been able to cover all this. So you can just go through your manual, and the value under example 4, we can also test it with a horizontal line. So we'll be learning that in the next class. Graph, we'll be learning graph majorly. So that's it. So, and this is our example 4. So we'll be cutting our example 4. So first answer, x squared plus 9x plus 19. Second one, x squared minus 5x plus 5. Yes, I think that's what we got. So the example 5. Yes, the example 5. We've gotten the example 5, the B. Yes, we are good to go. So now, the main reason for showing you this screen is for us to understand our checkpoint. Try to do all the checkpoints, then submit it. You have checkpoints here as well. Under this, we have checkpoints. So do the checkpoints by yourself, then submit it. You have the answer there. Try it yourself, then submit it. Then this checkpoint as well. this one, try this one too, then submit it. Let's see how we are coping. So that's it. Then submit it. So the next class we're going to be dealing with graph of function. So we'll be dealing with graph of function. So thank you.